So if you look at these characters, you can immediately see that they're different in proportions. And this is very typical with motion capture, right? If you're trying to put humanoid motion capture data on King Kong or on a little fairy, you know, the differences in scales can be drastic. The difference in length of limbs can be drastic. Motion Builder can handle these differences with no problem at all, and we'll see a couple examples of that. So the first thing we're going to do is we're going to go ahead and change the input. We'll put this back to frame 1 here. Get our guy up there on the skateboard. We're going to change the input of our character. Instead of being dragged around by that control rig, really what we want to do is have our character being dragged around by that motion capture data. And we're going to use the original version that hasn't been cleaned up. So by default, what Motion Builder is trying to do is it's trying to match joint angle. It's more concerned with matching the FK than it is concerned with matching the IK, which would be world position. That's great for certain things, but the problem is, because my character is a little bit bigger, he's not going to really line up on that skateboard. You can see as I kind of move forward in time here, he's not touching that skateboard at all. So that's the first problem we need to fix. We're going to jump into the character node for this lizard, and we're going to change its to have it match world position. So as soon as I do that, you can see that it's now matching world position. And look at the legs here. Notice that this lizard's leg is no longer matching joint angle. It's actually coming down and it's actually touching that same in position of where the original motion capture's foot is. That's because when I turn match position on, the character's feet have the little green circles. The little green circles means that I'm no longer concerned about matching joint angle. I'm more concerned about matching in position, or the IK handle if you would. So obviously if I drop this down, that value down, I'm now matching joint angle. So at any given time, while we're doing this retargeting, we can tell Motion Builder, what are we more concerned about, joint angle or world position? And then obviously his feet need to hit the skateboard, so world position is very important. If I wanted to punch somebody, you know, if I have short arms and I'm matching joint angle, I'm not going to reach that world position. I want to deviate from that world position to make sure you make that contact point on the punch. Same example with the foot here. So these are things that we're kind of modifying and finessing, and this happens. It's important to mention that all of these changes that we make to the retargeter are happening in real time. Now, I could expand this list out, and you would be amazed at the amount of flexibility and control that you can adjust when doing this retargeting. But in certain situations, you're not going to be able to get there, and you're going to need to layer almost, I can guarantee you actually, every time you're working with the motion capture, you're going to animate on top of it. You're going to clean it up, you're going to be making changes, and you're going to be animating on top of it. And that control rig gives us a great tool to do that. So what I did in this file is I've actually increased the size of the skateboard. So even if I told my hand to match world position, he's not going to grab onto the skateboard that's in the scene because it's in a different world position. So what we want to do is transfer this information onto that control rig, that HIK solver that we talked about earlier. This is a very fast, easy process inside of Motion Builder. All we're going to do is say plot or bake. So we'll put that information on that control rig, and now I have the ability to begin layering animation on top of that. So we'll grab a new animation layer, and what I want to do is I want to reposition that hand. So if we were to jump down to our hand here and start to reposition that, I could start keyframing offsets on top of this, which would be, you know, good for some situations. But for this guy, I know I want that hand to stick to that skateboard. I actually want to figure out a way to parent that hand into the skateboard. And inside of Motion Builder, we can create things called auxiliary effectors. What it is it's a new IK chain, and I can make as many of these as I need. So I'm going to go ahead and say create this auxiliary effector. That is now, if I display it there, it's that little green square. That is now what is controlling that hand. That hand has the reach value. If we expand this out, it's green. That means I'm trying to reach world position of that hand for both translation and rotation. So notice the effect when I scrub through this. My character's hand is always pointing toward that marker in space, and it touches it there for a while when he gets close enough to it. But notice that it doesn't have the ability to transfer that energy past the body part. Here's the cool thing. Because we have this HIK system in here, at any given time, I can start to dial in pull. This is turning on the amount that that body part is able to influence the rest of the skeleton. It's turning on that human IK solver. So if I crank that up to a value of 100%, you can see that that hand is really going to, you know, he's going to pull that guy a whole lot to try to get it to reach that world position. Now, obviously, we can just turn that off. So what we're going to do is we're just going to have that marker, this in marker right here, be parented into the hierarchy of that skateboard. So we'll parent that in, and what we want to do is just animate the value of this on and off. So we'll grab both of these guys right here. At that frame, we'll have it be on 100%. Obviously, we'll drop it down so that it matches the original joint angles there. So we're just sort of bleeding that on. He comes in, he grabs the skateboard, and just to speed this up, I can hold down the C key to copy keyframes. So I copied those couple keyframes there, and that is how we go through and clean up motion capture data inside of Motion Builder. Now, as I mentioned before, I had another version of the skeleton in my scene here, so we're going to change our source to be the cleaned up version. You can see it's a little bit different there. I'm going to replot that back onto excuse me, that control rig so that it cleans it up through the whole range there. So it just does sort of the same thing that we just did on this one portion. It just did it throughout the animation. So as we scrub through this now, you know, when he comes down here and he does this little McFlip, he does a nice tail grab on that, and then he comes up here and does this kick flip. And again, you can see that as he does that, he gets this really nice kind of natural movement where that hand comes in there and grabs the board. So now that we've got our motion capture data applied to our character, again, everything working in real time. That's what Motion Builder brings to the table, is this virtual production real-time aspect. We want to get that back over to Maya. And how do we do that? Well, we do it with a single-click workflow. So I'll select a body part just to tell it what I want it to send. We'll say send to Maya, update current scene. It'll pop Maya to the foreground here. And now you can see if we just start at frame 1, which we're at, I can jump over to this camera here, this half pipe cam, clean up the display a little bit. We don't need to see that stuff. We play this back. What we have inside of Maya now is that same movement. So all the work in Motion Builder, single-click workflow right into Maya. Very cool technology. The next thing that we need to do is start to modify this a little bit. I'm still not 100% happy with this guy right here where he looks a little compressed on that. So what I'm going to do is I'm going to start to add some animation on top of this. Now all that information, all that animation lives on the control rig. This gives me the flexibility of doing layered animation and having the power of that HIK solver to assist me in doing that character animation. So what we're going to do is we're going to create something called an editable motion trail. Editable motion trails they were new in 2012 of Maya. Awesome feature. This is one of the things that if you're an animator and when you got 2012, you were excited. It's so well thought out. It does things so elegantly. It's awesome. We'll turn this on. I'll make sure they have the option set. I want it to be on for 50 frames. Pre and post my current frame. We'll have it show the frame numbers, and we'll create that editable motion trail. And it's like my display is not set to display those guys, so we'll display that. So what we have here, just so you can see the effect of the pre and post frame, it sort of bleeds on and off based on where my character goes. And the reason I did that is because this guy goes back and forth the ramp a few times, and if I just had it on the whole frame range, it would just be a squiggly line. It would be hard to understand. So that pre and post frame kind of assists me with that. So what are we presenting with here? Well, obviously we've got dense data. It's motion capture data. It's sample data. There's a lot of subtleties in there. If you look at here, you'll see this little, kind of subtle little bop in the movement there. I want to make this character go up higher and try to move all those keyframes and maintain the subtleness of that motion capture data. Would be very difficult to do. So what we're going to do is we're actually going to make a new animation layer, and we're going to introduce that modification or that tweak on a separate layer. So there's two advantages of doing this. Number one, it gives me something that it puts a very sort of high-level control. I'm just setting a keyframe there, a keyframe there, and a keyframe there. So now what I have is I've got very high level of control over dense data. I've got 3 keyframes, and it's an editable motion trail. That means I can grab a keyframe on that motion trail and edit its position. So you notice that it's just given me an offset, but I still have that really nice, subtle movement inside of there. It's also worth mentioning, this is being done on the HIK solver, so notice the effect. His feet will hit that skateboard when I compress him back down. The power of combining HIK with editable motion trails is significant. It's really, really cool. The other thing that's kind of nice about this is we did it on the animation layer. So the second advantage that I talked about previously is the fact that I can turn on and off the effect. I can also adjust the weighting of that layer. So it's a very nice, fast, non-destructive way of taking dense data and editing it with a level of high level of controls. The next thing that we're going to talk about really quickly here is a couple of the other advantages that came in the Subscription Advantage pack. And that is Bullet. So what Bullet is it's a physics engine. Maya has a variety of different physics engines. This is yet another one. It's an open source technology, so our clients like Disney used it on Bolt. What it is it's a rigid body solver that has the ability to also do soft bodies. So the rigid bodies and soft bodies can interact with each other. For those of you that aren't 3D people, soft bodies are deforming objects, flags, cloth, bags of potato chips, things like that. Rigid bodies are what they sound like. They're rigid and they're just kind of fall like a computer would be a rigid body. So what we want to do is we want to use this bullet engine to add some life to this scene, some dynamics to this scene. The other thing that Bullet brings to the table that's kind of interesting is it's got a variety of constraints that you can use. So by having constraints with rigid bodies, we can create ragdolls. So that's what we want to do on this character's tail. Is I want to make a ragdoll simulation to give me that dynamic secondary movement. So we'll go ahead and we'll create the ragdoll. I'm just going to run a little script that joins that back into the hierarchy. And what we have done is we've essentially gone through for every one of those joints and created a collision capsule. It's a primitive shape. It collides very quickly. Those primitive capsules are joined together using the constraints that I talked about. Let's pop that one. Come on. Got a little slow there for a second. Hope that's not a bad sign. We'll keep moving forward here. The constraints are kind of smart. This obviously is set to be a 6 degree of freedom constraint. It knows to look to the joint that it was derived from to establish its rotation limit. So I wanted my tail to always kind of maintain that kind of nice curl or kink to it. So I set rotation limits on those joints. If I look at my limits for this selected constraint, you can see that it's been limited in X, Y, and Z, positive and negative. So min, max, and X, Y, and Z have been set. Also, it has properties that adjust how much dampening that's going to have. So the joint limits and the dampening values go into making the overall feel or effect of how that ragdoll is going to behave. So that's pretty straightforward. Let's go ahead and just play this back really quickly. We can jump over to our camera. So now we've got this nice dynamic secondary movement happening on that character's tail. The next thing that we want to do is just add in a few more objects. Let's just pop that guy and get back to my control box here. Display layers, we'll put bullet on. So I've got these other objects in my scene. I want to have them be rigid bodies, so we'll select them all, accept that bag. We'll create the rigid body for this guy, so it'll go through and think about that. Actually, I'm going to create an OGS reset there. So I'm running a beta version of this. I should mention that. So when I created the rigid body, the OGS draw lost what it was. So I just had a little, this guy right here is just, the command is OGS-reset. So if anybody's using mine, something weird happens in your view, or OGS-reset will reset it for you. Let's go ahead and create this into a cloth object. We'll add some attributes on that guy. We'll go ahead and change the parameters. Actually, we'll play it back once wrong. So if we play this back, let's make sure we're in our perspective view so our camera's not moving. The geometry is not going to drop very fast. So I want to modify the world in which this lives. We're just going to multiply that, put that up to minus 980. There we go. So now they'll drop realistically. And just like that, we now have a really cool dynamic solve happening, objects coming down, soft bodies interacting with rigid bodies, constraints holding our dynamic tail together. And the last thing that I want to mention that came into the Subscription Advantage pack is Alembic. So what Alembic is again, it's another open source technology. At Autodesk, we really try to embrace what is or becoming industry standards. So things like Alembic, EXR, these are open source files, open source formats and projects, but it's what our clients are using, so therefore it's what we need to support and what we need to do. Alembic is a caching file format. Again, open source, made by ILM and Sony Picture Imageworks. And one of the unique things that it does is, number one, it's ridiculously fast. Number two, it can handle changing topology. So what that does is it lets us do things like take meshed particle systems or meshed fluid solves and save those out as caches that are proprietary. The meshed fluid solve would be proprietary to Maya, but I might need to get this into another application that doesn't understand it. Or I'm working with a bunch of facilities and I'm doing 10 shots and they're doing 10 shots and they need to take my cache because they're going to do the rendering. This lets data be changed back and forth between facilities very easily, or move data through your pipeline or your partner's pipelines very efficiently. So what we do to create an Alembic cache is we just say import or export Alembic. We'll call this one something like, let's do an export selected. And that's fine. Export selected, and we'll just call it new. So this is going to go through. It's going to export this out. I'm only doing 20 frames. It's worth mentioning that it gives me a speed improvement. So now that I showed you how fast it would export it out, I'm just going to delete that guy because I don't want to take any of Will's time. I know he's anxious to get onto this shot and finish it for me. Take all my stuff and make it actually look good. That's the big box's job. Will, creative finishing. Let's go ahead and just import in that Alembic file. So we'll import the Alembic file in. This is great. The kind of cool thing about this is because it's a meshed file, actually the geometry is stored in that Alembic file also. And I know that since I did that cache, I've changed my demo and slid my whole scene over 150 units to make it look better. But what this gives me is it gives me the ability to now scrub this because it's just points on space coming from disk. And you can see that obviously that's changing topology. So that's what Limbic's all about. I mentioned that I want to send this to Flare. We can send geometry to Flare. We can send animated geometry to Flare, again using caches, and render passes. So I've got my scene broken out into several different passes, and those passes are broken down into individual lighting components. So we separated it out at an object level as well as a lighting component level. And we want to take this into Flare and do some really cool atmospheric effects, some relighting stuff, maybe even change some of the cameras. We have a ton of downstream flexibility because we're sharing both geometry information as well as beauty information and render pass information, all in the form of OpenEXR files, multi-channel OpenEXR files.
Cool. Yeah, awesome, Daryl. It looks so cool, and I'm going to make it look even better, hopefully. I'm working here in...
Quickly, you have 15 minutes, because I went long, so sorry.
I'm working here in Autodesk Flare, and this is a compositor that you might consider using, especially when you want a high level of interactivity when working with your... a comp like this that's really just an organic piece. What I've got here is I've got my EXR render layers. So this is essentially the output that would be produced. I've got essentially a beauty or reference here that's pre-tone mapped for me. Everything else in here, you can see things like UV pass, which we'll come to in just a second, but let me take all the raw pieces here, and I'll just switch into my scene linear mode and set an exposure, the sort of a working exposure that I like. I would dial this in for real with a proper photo mapper or tone mapper at the end of my pipe, but I'm going to just go ahead and just spin through my assets so you can see that we deliberately broke things into layers to allow more flexibility, and you'll see just why. I've got my my comp here with the different pieces, so this is to be a standard essentially diffuse, essentially a lighting diffuse all the way through to a specular and incandescent build of your shot here. So putting render passes together is pretty basic. Hopefully you understand that that matches a beauty. But what if essentially you need to take this further? Why would I need a compositor with the horsepower of Flare or even Flame to do this shot? Well, one big differentiator that you're going to be able to see is the ability to bring in geometry and work with it very quickly. So we have a high performance GPU accelerated geometry engine here. And this is how we're able to work with material like this. We're using a node called Action, which is our 3D world space environment. And you can see, if I just show you the wireframe view real quick here, that every piece of geometry that Daryl was making there is available to us in the scene. So you can see the background all the way to the mountains, actually. You know, the different pieces, the diner, and what I've got here sitting in the foreground, if I can just select him, there's a lot of pieces in there. Let's just select my my lizard guy, and there he is. He's this guy right here. We'll just grab that. This is animated cache. So this is a moving character, and no scripts needed. Essentially, you can just work with this and project your renders onto it. So that's what we're going to do next. What we do is we just essentially take this guy. We might actually throw in some ambient occlusion to really refine the way this looks in our environment. You can see how useful it is to have that realism, that level of realism via ambient occlusion. But what we'll do is we'll throw in one of our render passes here real quick so you can see how this works. By taking, just take the beauty for now. I'm going to grab one of these passes. So let me just grab this one down here, the beauty. And I'm going to wrap this around the scene. So here's all the pieces. Here's an image which we don't want. What we want to do is we'll just drill in here and use the image as a projection, or in our case we're going to use what we call a diffuse map in projection mode. So if I just drag that out, what you'll be able to see here, it's over here actually, is that I'll start with the ramp here, and you can see how when I attach this to the ramp, I get essentially a UV wrap, which is not quite what I want. What I want is a projection wrap. So I'll jump in here, switch this to projection mode. Let's just take a look at it, how it's going to look. You can see it looks just like the essentially the original, except now we're projecting on geometry. Let's loop that into the other pieces of the scene, and you'll really get the idea that the reason to do this is to allow you to work in a much more interactive way than just working with renders. Let me just remind you that what I have here is a scene that's laid out in space. if I just look around it, you can see, especially if I just come in here, I'm going to take an extra perspective camera here, just dolly back in space, and you can see how powerful it is to have your scene projected.
Turn shading off too.
So it's really just a neat way to reproduce the image from a lot of perspectives. And this is just a great flexibility for adding, essentially, if you want to change the camera move a little bit, if you want to add camera shake, you can see how far around we get before we start to see artifacts. It's kind of crazy, huh? However, we've got a problem. We're using a single baked layer to project on our entire scene. That's why we see the skate ramp in the diner. That's why we see on various frames our lizard essentially up here. We don't have a layered projection yet, so that's the next thing we would do. Let me just move ahead in our pipeline here so you can see how a layered projection gives you just the pieces you need, not kind of falling onto each other, if you like, or appearing on each other. It's a neat technique. I'll just give you a quick tour of this environment. You'll be able to see how now I've got control further, so you could really get those extra camera moves. He's not being wrapped essentially with the same layer. The different layers are dealing with the diner, the sort of foreground, midground, background. So you can just see the flexibility this would win you. And then I've got a big essentially HDR image in the background right now. If I just move through the scene, you could get an idea that another advantage of working in this way is that you could actually take 3D things and make them interact in your environment. So what I'll do is because I've got the geometry laid out, I can start making changes to lighting. Specifically, maybe, Daryl's done a beautiful job here, but if we want to just take it over the top with essentially a 3D aware effects process, that's what I'd like to show you. I'm going to add one of our relighting characteristics called blooming to this light. So if I want to really make that diner sign come alive, I might throw in some of my blooming here, and what I do is I essentially, let me just grab this guy right here, you'll be able to see what I mean. So I've got a light here, there's my blooming, and what I'll do is I'll overdrive that for you so you can really understand that maybe if I just refine this down a little bit, get it exactly the way my client, and that might be Daryl, wants it, and you can just see how this is a 3D process. This is essentially reacting with that geometry. If I just move around here again, you can just sort of understand how this is all part of the process. A selective light, just working with that geometry. So this is cool to be able to do this kind of stuff. Of course, I could make it pink or green or whatever color you might want, right? But just to really bring this alive, you can see that there's a sort of an element of light that might be missing here. I'm going to take a light that I just placed in the background there and throw on a lens flare. Excuse me, I'll start with some rays, and I'll throw a lens flare. So let's just attach rays to that guy. And what you'll be able to see is that with a tiny bit of adjustment here, maybe I'm just going to over crank it a little bit here, you can see real volumetric lens rays appearing in our environment. So I'll be able to drag that light around here. You can see how things react to the object. This is not essentially a 2D stamp-on effect. This is an integrated environment that we're working in. So we've got 3D light that's essentially reacting with 3D geometries with the renders wrapped over them. It's just a really flexible way to get exactly what you want. So you can hopefully see that the performance here is still, we're really not stopped down by throwing all this stuff together, multiple layered projections, bringing my lights into the environment, changing up the way they're going to look, setting the light to interact with the geometry physically. So it's pretty powerful to get this kind of level this late in your pipeline, this kind of power in your pipeline. So if I've just about got time, I'll just throw on let's take a lens flare, and we'll throw that on my Sunmaker. I'll just about the rays for a second, and let's put on a lens flare in there. So one more tool. There's a whole bunch of them in here, but I might just play with a lens flare. This is a bunch of components in a package that I can play with. I'll just intensify that a little bit for you. We have a bunch of presets as well that you can work with. I'm going to just overdrive this a little bit and swing it around so that you can see how I could work with this. I could switch it over to orbs. I could customize my lens flare. Maybe I'll just settle on a kind of a caustic here. I've got different types of caustics I could play with. Let's have a look. See, maybe I want something like that. but I want it a little more, you know, blurred out. Maybe I want it a little larger, play with it a little bit more. Let's just go back to my basic tab here. I'm going to just play with the exact position of it and get something that looks like that. So this is all going to react in 3D space, so you can see how things are swinging around, reacting like a physical light. If I just move this light around the environment here, you can really get the idea that it's behaving as it should do. I can even control independently if I like the pivot of the light. I can really jump in there and have some fun with it. All right, one more cool little thing that we wanted to show you is a further way that you can manipulate the elements in your scene here is via UV pass extraction. So one of the passes that's available to me here, let me just move over a little bit here so you can see what's up. I'm just going to move this guy clear of what I was working on before. And what we'll do is we'll actually jump into one more little trick that we are able to do here, one more functionality that really helps you with flexibility. Remember, one of the passes I had was a UV pass. It looks like this. So this is essentially the coordinates information for that ramp along with any other things that you put in there. So what if you wanted to replace what was on the ramp, or you wanted to add on to it, for example? The way I would do that would be with a specific technique here. I'm just going to pull out one of my action nodes again, and it has some new cool functionality that we added recently, where I can take essentially a standard image. Let's just take a graffiti image here. It looks like this. So it's just a flat image. It's a still. It's just a UV, essentially designed to be a UV. We'll use this alpha channel as well. And then I'm going to connect in another pass here, which is going to be my UV pass. And I want to show you how these can interact with each other. If I jump in here, you'll be able to see an image is not how we want to use it. We want to use it a special way. We were using projection and diffuse mapping earlier. But what I want to do now is I want to throw in this same source in a special way. This is what we call a UV map. And you'll notice as soon as I throw it in here, it's going to instantaneously essentially distort that UV in the perspective that is designed for this. And you can see how that works as a ramp. If you want to get into some of the granular detail, you have artifacts such as the edges of this plate are appearing. So you see how you've got extra UV data in here that we don't need. I would take advantage of my object IDs. So in the blue channel of a UV pass, you have the ability to go pick, I want just ID 3, and you can see that isolates out just the ramp. And now I've got a nice clean ramp thrown in there. Of course, what I would also need is the manipulated alpha out. So I'll take this guy and make it into a mat, and then I'm going to come in and feed this into my pipeline, right? So this is just an extra comp node upstream, and I'll take this and output it, combining it with the ramp upstream of its lighting characteristics. So what that means is that it's going to feed in and it's going to get all the lighting attributes of the rest of the sequence. So it's really cool to just take a minute here. You can see this is the my graffiti thrown in with the shadows that are needed on this ramp through and along. So it's a great flexibility. We could go look all the way at the end of the pipe to see that, but of course it's pretty obvious, I should think, that you can imagine my procedural compositor can now help me even further, as I can slug in here if I'd like a bunch more pieces. So if we just drop in a paint node here, I can actually get this looking really cool. I could actually, if I wanted to, jump in here and maybe add a little of my own graffiti. Let's just do a real quick throw in here of something that looks a bit like this. So my tag is going to be like this. Maybe we'll just add a little smiley face over here as well, over that guy's stuff. That's rubbish. All right, so good fun. All the way at the end of the comp here, I'm going to just take a look one more time at the finished sort of article here. We haven't yet thrown in our depth for depth of field, rack focusing here, or motion blur. But just so that you could see that, let me take one last example here and just show you how that looks. So all the way here we have just a sort of something we worked on, tuned up a little bit. Hopefully you can really get the idea of the power of working in this kind of compositor for this kind of work, throwing in depth mats, essentially expanding out the process of this to be able to see a finished result here. Bear in mind, that's all that projection is feeding this pass here. That's my depth of field. Here's my motion blur that is going on top of that. You can see he's moving pretty fast during the ramp, and then we come back to the head here, he's standing still, and then out via the tone mapper that we talked about. So this is just a really cool solution. Hopefully you can understand the value of being able to go from your original source all the way to something that looks like this. So let me just loop this real quick for you, and we'll do this so you can just see how far we could take it. Kind of cool stuff. Well, we've run out of time, guys, so thank you so much for listening. You've been watching our presentation of the Maya Entertainment Creation Suite with Flare, and we wanted to show you a couple more links of our area site, which is a great community with blogs and tutorials and training if you need access to it. So don't forget to check that out.